Dear students, in this session we are going to see the concept of mole. What is mole? Mole is the amount of substance of a system which contains as many elementary particles as there are in 12 gram of carbon 12 isotope. Carbon 12 isotope. We take 12 gram. In that, how many atoms are present? We may not be knowing. And any substance which contains that many particles is said to be a mole. And that many particles later on desired as 6.0222 into 10 power 23. So mole is the amount of substance of a system which contains as many elementary particles as there are atoms. As many elementary particles as there are atoms in 12 gram of carbon 12 isotope. So in 12 gram of, if you take 12 gram of carbon, in that we will be finding certain number. That number later on desired like this. If we have that many atoms, that quantity is said to be 1 mole. The quantity of substance which has got that many atoms, 6.022 in 10 power 23 atoms is said to be a mole. It may be any particle, any fundamental particle. It need not be for atom like carbon. It may be for molecule, it may be for ion, it may be for electron, anything. Whatever it may be, if we have 6.022 in 10 power 23 particles, that many particles put together form the quantity 1 mole. That we should understand. The particles may be atoms, molecules, ions, or anything. Any fundamental, it may be electrons. You may talk about electrons, protons, anything. Let me take, we used to see atom is very, very small, that cannot be visualized. But we can see mustard seed. The approximate mass of 1 mole of mustard seed, that is 6.022 into 10 power 23 mustard seeds, if we take, that may have approximate mass of 3.10 power 21 gram, gram. So it will be gram. 3.3 into 10 power 21 gram. These many mustard seeds. What does it mean? If I have 3.21 gram of mustard seed, I can very well say I have 1 mole, because 1 mole corresponds to these many. Whenever I have these many, I can say it corresponds to 1 mole. So 1 mole represents a quantity which consists of 6.022 in 10 power 23 ultimate particles, fundamental particles, which may be atoms, molecules, ions, anything. I can refer anything. Usually for mustard we won't refer because it is a huge mass. When I calculate what will be the mass of 1 mustard seed, it will come to like this. Mass of 6.022 into 10 power 23 is equal to 3 into 10 power 21, and therefore what will be the mass of 1 mustard seed? If I calculate, it will come to 1/2 approximately, and if I divide, it will come to 10 power 2 at the denominator. So 2 into 10 power 2, when 10 power 2 go over to the numerator, it will become 10 power minus 2. 0.5 into 10 power minus 2 gram. That means you will be getting 0.005 gram. So approximate mass of a single mustard seed may be 0.005 gram. So you can take 500 gram or 50 gram of mustard at your house, and you can start counting. Based upon that, you can find out the mass of 1 mole of mustard seed. You can very well do, because it is lockdown period. Take 50 gram of mustard at your house, get from your mom, weigh 50 gram, count the number of mustard seeds in that, and then 50 gram has got these many. For these many mustard seeds, the mass is 50 gram. Therefore, what will be the mass of 6.022 in 10 power 23? If you find, that will give mass of 1 mole of mustard seed. Suppose in 50 gram, in my calculation it comes to each mustard seed is having the mass 0.005 gram. You may do your own calculation. That is, in 50 gram, how many will be present? 1 is equal to this much. 1 mustard seed has the mass of 0.005 gram means 1 mustard, and 50 gram means how many? That is the calculation. So, it is 5 into 10 power minus 3. When it goes to the numerator, 5, 10, so which comes to 10 into 10 power 3. So, approximately you may have 10,000 mustard seeds in 50 gram. Whether it is so or not, you just verify. What do you think I said? Number of mustard seeds in 50 gram. This many is having this much mass, and this many will have how many mass? So, mass of 1 mole of mustard seed will be like this. You can very well say. In practice, we have seen 1 atomic mass will have Avogadro number of atoms. 1 molecular mass will have Avogadro number of atoms. That's what we have derived. So, what can I say? Mass of one atom of 1 atomic mass, 1 gram atomic mass in gram. So, mass of 1 gram atomic mass. That means atomic mass expressed in gram. Atomic mass expressed in gram for carbon is 12 gram. For oxygen it is 16 gram. Likewise, for hydrogen it is 1 gram. So, mass of 1 gram atomic mass of any element. Number of atoms present in 1 gram atomic mass of any element is equal to Avogadro number. If I take Avogadro number 6.022 in 10 power 23 atoms, it will correspond to its atomic mass. Likewise for molecule. For carbon dioxide, molecular mass is 44. 44 gram of carbon dioxide corresponds to how many molecules? 6.022 in 10 power 23 molecules. So, 1 molecular mass of any substance in gram will contain Avogadro number of molecules. 1 atomic mass of any element in gram will contain Avogadro number of atoms. So, that is a very simple concept of mole. Now I can relate, and I can also relate few more things which is not directly given under this heading now, but it will be useful to you. 1 gram atomic mass of any element, 1 gram atomic mass. What is the meaning? Atomic mass of an element in gram. Atomic mass of an element in gram, that is said to be gram atomic mass, corresponds to, it will contain Avogadro number of atoms, 6.023 in 10 power 23 atoms. We said 6.022 in 10 power 23 atoms. These many atoms put together we call 1 mole. So, 1 mole of a substance will have the mass equal to its atomic mass. Atomic mass expressed in gram. Atomic mass of an element expressed in gram will contain 6.022 in 10 power 23 atoms. That many atoms put together we call 1 mole. So, 1 mole represents the amount of substance. Its mass will be equal to its atomic mass, and that will contain 6.022 in 10 power 23 atoms. Let me explain with an example. Say oxygen. For oxygen, what is the atomic mass of oxygen? It is 16. If expressed in gram, we say gram atomic mass. Gram per mole we used to say. I said already very clearly, 16 if I write, it is relative atomic mass, mere number. If it is written in U, It is unified atomic mass, corresponds to 1 atom of oxygen, mass of 1 atom of oxygen. If I express in gram, it is the mass of 1 mole of oxygen atoms. 1 mole of oxygen atoms means correspond to these many atoms. So, if I have 16 gram of oxygen, which is nothing but 1 atomic mass, 1 gram atomic mass of oxygen, it will have 6.022 in 10 power 23 atoms. That many atoms put together is said to be 1 mole. And 1 mole of oxygen atoms will have the mass equal to 16 gram. So these three are interrelated, that you should keep very well in your mind. 1 mole of any substance, any element will have Avogadro number of atoms. And Avogadro number of atoms, if you weigh, it will be equal to its atomic mass. The atomic mass of the element is said to be 1 mole. The reverse, 1 mole of any element will have the mass equal to atomic mass. 1 gram atomic, 1 gram atomic mass means atomic mass expressed in gram, corresponds to 6.022 in 10 power 23 atoms. It is for an atom. If I go in for molecule, little bit I can add molecular mass of a substance, molecular mass, again in gram, corresponds to Avogadro number of molecules. When I say molecular mass, I should say molecules. These many molecules put together, I will be saying 1 mole of molecules. I have 1 mole of molecules. And that 1 mole of molecules in gaseous state will contain 22.4 liters at STP. At standard temperature and pressure, it will have 22.4 liters. That's an approximation I given, very simple. So, 1 molecular mass of any substance in gram corresponds to Avogadro number of molecules. That many molecules put together we call 1 mole, and 1 mole of a substance at STP in the gaseous state. 1 mole of any substance in the gaseous state. If it is in gaseous state only, it is applicable. It will have 22.4 liters. It is said to be molecular mass. What does that mean? 1 mole of any gas at STP will have 22.4 liters, or 2.24 in 10 power minus 2 meter cube. If expressed in meter cube, 2.24 in 10 power minus 2, 3 meter cube. And this much volume of any gas at STP will have 1 molecular mass of a substance. And 1 molecular mass of a substance in gram will contain these many molecules. And 1 mole of any substance corresponds to its molecular mass. If I have a molecular mass of substance in gram, it is said to be 1 mole. If I have Avogadro number of molecules, gaseous molecules, it will have 22.4 liters at STP. 22.4 liters of any gas at STP will have these many molecules. Those 4 are interrelated, and I can relate like this. How? Let me take molecular mass of carbon dioxide. Carbon 12, 2 into 16, 32, sum is equal to 44. So 44 gram is the molecular mass. 44 gram of carbon dioxide will contain Avogadro number of molecules, 6.022 in 10 power 23 molecules. 44 gram of carbon dioxide will contain these many molecules. These many molecules put together is said to be 1 mole. And 1 mole of carbon dioxide at STP will have 22.4 liters. And if I have 22.4 liters of carbon dioxide, it will have the mass equal to 44 gram. Or 44 gram of carbon dioxide is said to be 1 mole. 1 mole of carbon dioxide is said to be 44 gram. Liters of carbon dioxide is. So 1 mole of carbon dioxide will have the mass equal to 44 gram. If I have 6.022 in 10 power 23 molecules of carbon dioxide, it will have the volume equal to 22.4 liters. Or 22.4 liters of carbon dioxide at STP will contain 6.022 in 10 power 23 molecules. If you are able to understand this point, you are well versed in mole concept. The fundamental, there is basic concept, very basic concept in chemistry is mole concept. Many may not be understanding clearly what is mole. Mole is nothing but a quantity which is representing the presence of these many atoms, molecules or ions. If these many atoms are present, the mass is said to be atomic mass. If these many molecules are present, the mass is said to be molecular mass. Only in the case of molecule we are coming in for molar volume, 22.4 liters at STP. Little bit changes are also made, approximately 22.4 liters. So this is the concept of mole. Now let me explain the concept of mole with an example given here. What is it? They have taken elemental carbon. Carbon is taken as an example. In the book, 2-3 examples are given. Let us start with carbon. Carbon 12. Carbon 12 isotope means naturally atomic mass, gram atomic mass will be 12 gram per mole. Likewise only we will be saying. So mass of single atom of carbon is found to be 1.9926 in 10 power minus 3. This number we need not memorize. 1 mole means 6.022 in 10 power 23 atoms will have 12 grams. Therefore, 1 atom will naturally have this. They have weighed. 1 atom of carbon is found to be 1.9926 in 10 power 23. That is the mass of 1 atom of carbon, right? Now, how many atoms are present in 12 gram? So, in 1.9926 into 10 power minus 23 gram corresponds to 1 atom. Therefore, 12 gram corresponds to how many atoms? So, mass of 1 atom of carbon is this much. That means this much mass of carbon corresponds to 1 atom. 1 atom of carbon. 1 atom of carbon has this much mass. This much mass means 1 atom of carbon. Therefore, how many atoms will be present in 12 gram we are calculating. So, the number of atoms you will be getting will be, when 10 power minus 23 go over to the numerator 10 power 23 minus 23 become plus 23, approximately 2, so approximately 6, so 6.022 you will be getting. These many atoms are present in 12 gram. That is said to be 1 mole. That's why we are given per mole. So these many atoms of carbon are contained in 1 atomic mass of carbon. If we go in for atomic mass, 1 atomic mass of any element will contain these many atoms. That's the proof we have given now. And 3 more examples they are given in the book. What are the examples? Yet another example, glucose C12H22O11 molecular mass, sorry, C6H12O6. 6 into 12, 72. 12 into 1, 12. 6 into 16, 96. If you sum up, it will be 180. 180 gram, I can say gram per mole also. Nothing wrong in saying like that. So, molecular mass of glucose in gram is said to be 180 gram. What is the mass of 1 molecule of glucose? Mass of 1 molecule of glucose, sorry. Yes, mass of 1 molecule of glucose. Molecular mass is this much. Mass of 1 molecule of glucose is given as 29.89 into 10 power minus 23 gram. If we take just 1 molecule, what is the meaning of just 1 molecule? We should take only 6 carbon atoms, 12 hydrogen atoms, 6 oxygen atoms. And based upon that, if we calculate, it comes to 29.89 10 power minus 23 gram. It is the mass of 1 molecule of glucose. Then I can say in the other way, 29.89 in 10 power minus 23 gram of glucose contains, glucose corresponds to 1 molecule. Therefore, 180 gram of glucose corresponds to how many molecules? If we calculate again, when minus 23 go over to the numerator, it will become plus 23. It is approximately 30. If you divide, you will be getting 6. 6.022 in 10 power 23. That means one molecular mass of any substance, any molecule will contain Avogadro number of molecules. That is said to be mole. Likewise, two more examples are given. One for potassium dichromat, another one for potassium permanganate. Both these examples, let me give. Or you can think yourself. Molecular mass of potassium permanganate 294 approximately gram. It is for potassium permanganate. And for, potassium dichromat is for potassium dichromat, K2Cr2O7. For potassium permanganate, it is given as 158 gram. I can say gram per mole because 1 mole of molecules contain this much mass. And actual mass of 1 molecule of potassium dichromat, mass of 1 molecule of KMnO4, K2Cr2O7 again, is equal to 48.851 into 10 power 23. If it is potassium permanganate, 1 molecule, 26.242 in 10 power minus 23 gram. I think you can understand. The thing is, 1 mole potassium dichromat, gram per mole. If you take just a single molecule, it is found to be 48.851. That's what given. Mass of substance taken, gram. That is 1 mole of substance. That means I can say 48.851 into 10 power minus 23 gram of potassium dichromat corresponds to 1 molecule of potassium dichromat. If I take 1 molecular mass, that is 294 gram. Suppose if we take 294, I need not say gram per mole also. Suppose if I take 295 gram, it corresponds to Avogadro number 6.022 in 10 power 23. All right. It's taken over there. 48 divided by 2 approximately 6.022 in 10 power 23. These many molecules are contained in this much, and it is said to be 1 mole. Gram per mole we say. That's all. Likewise for potassium permanganate, 26.24 in 10 power minus 23 will contain 158. Will have 1 molecule. Therefore 58 gram will contain how many molecules? That corresponds to 6.022 in 10 power 23. That means 1 molecular mass of any substance will contain this many molecules. 1 atomic mass of any substance will contain 6.022 in 10 power 23 atoms. Atomic mass means atoms. Molecular mass means molecules. How many? 6.022 in 10 power 23. That is said to be Avogadro number. And the Avogadro number of any gaseous molecules will have molar volume 22.4 liters at STP. So that is about the concept of mole. Thank you.